Example 3. Let's do example 3 for real instead of me changing the instructions on it. We proved it yesterday, but what question 3 was actually asking us to do was to derive a composite identity for sine using the cofunction identity for cosine. Okay? So how are we going to do that? Well, I'm going to come over here and I'm going to say sine of x plus y. Okay? I'm going to treat x plus y as a unit. All right, so here's the cofunction identity I'm going to use. I know that sine of a is equal to cosine of pi halves minus a. Would you agree? So let's just call all of this a for just a second, the quantity. So sine is going to be equal to cosine of pi halves minus parentheses, the quantity, x plus y. Are you okay with that? Thank you. Y'all are so agreeable this morning. All right, now let's distribute the negative, and we get pi halves minus x minus y. All right, now what I'm going to do is I'm going to associate the first two terms together instead of originally what was associated the last two together. All right, now I'm going to use the composite identity for cosine that we already learned. Let's write it off to the side. Remember, cosine of a minus b was cosine a, cosine b, plus sine a, sine b. You agree with that too? Okay, thank y'all. Well, I'm going to treat this now as a quantity A, and I'm going to treat this as B, all right? So this is going to be cosine of the first angle, pi halves minus x, times cosine of the second angle, y. And then plus we change the sign, sine of the first angle, which is pi halves minus x, times sine of the second angle, y. And now all I got to do, now,
Could you group x and y together as well?
well, that's how we started. We started by grouping x and y together.
So could you not split it up from the x?
I can, but it wouldn't give me the result I wanted. The reason I wanted to group the pi halves minus x together, Brady, is so that when I get to this step here, it turns into the cofunction identity. Yeah. Cosine of pi halves minus x now turns into sine of x times cosine of y, plus sine of pi halves minus x turns into cosine of x sine of y. Okay. Now there we have it. This, if you bring it all the way back down from the very top, this is equal to sine of x plus y. Now the way I like to do it, let me review how I like to do it. I like to change the order a little bit. I like to leave it as sine x cosine y, and then I like to go sine of y cosine of x. Okay? In other words, I like to keep my trig functions in order, sine then cosine, rather than the line above, which keeps your angles in order. Either one is fine. I just prefer to do the trig function, keep the trig functions in order, and then switch the angles. Okay, so this is what we're going to do for sine, because remember, sine is not selfish. Sine is what? Selfless. So here's how I remember it. Sine has his name on the identity, so the law says sine has to go first, just like cosine went first. But sine, unlike cosine, says, hey, I'm going to go first. I'm going to take the sine of the first angle, kind of like you're distributing. But because sine is selfless, sine goes like, hey, I just had a turn cosine of x. Why don't you go next? And cosine's like, you're darn right I go next. And it's cosine of the second angle. And then because sine is so selfless, we don't change the sign. We keep the sign. If it's plus here, it's plus here. Sine, same sign. Sine, same sign. Sine, same sign. And then we do the same thing. Now it's sine of the second angle times cosine of the first. Okay? So for sine, we trade off. Sine of the first, cosine of the second. Sine, same sign. Sine of the second, cosine of the first. I like to keep the trig functions in order. And then I just switch the angles on the back end. So the first thing that you look for is like you're distributing. It's going to be sine of x. Sine of x, just like you're distributing. And on the last one, it's sine of the other angle. Now, what is it for sine of x minus y? It's the exact same thing, except It's a minus sign. Sign, same sign. Sign, same sign. Sign keeps the sign. So you can summarize both of them like this. Sine of x plus or minus y is sine of the first, cosine of the second, plus or minus. Sign, same sign. Sine of the second, cosine of the first. Sine, same sign. Sine, same sign. You want to try that for yourself? Sine, same sign. There's a lot of cool things you can do with the sound of sine, right? Like sine, y, height, y, sine, height, y. And then sine, same sign. Sine, same sign. Sine, same sign. Got it? You memorize them? I'm trying to give you a way that you can tap into your memory to have them memorized more easily. Okay, let's try it. Use the composite identities to prove the following cofunction identity. All right, so we proved the cosine identity. Now let's prove the sine identity. All right, I'm going to draw the line down the middle. I got sine of pi halves minus x. That's a composite angle, isn't it? I know it's equal to cosine. I've memorized that, but we're trying to prove it. So I can use the sine identity. So for sine, I'm just going to pretend like I'm distributing it first. So it's sine of the first. And then sine being selfless says cosine. Now it's your turn. And so it's cosine of the second. And because it's a minus sign here, it keeps the same sign. Sine, same sign. And now it's sine of the second angle. They switch angles. Okay, they switch angles. Sine of x, cosine of the first. Again, I like to keep my trig functions in order. Sine, then cosine, sine, then cosine. The law says sine has to go first because his name is on the identity. That's the law. All right, now we evaluate. What's sine of pi halves? That would be 1. So I get 1 times cosine of x minus sine of x times what? What's cosine of pi halves? 0. So I get cosine of x minus 0, which is cosine of x. Fear the fabulous horn. By the way, we're doing baseball send-off today, but there's not going to be an announcement. I'm not going to come on the intercom because teachers are tired of me interrupting their class. That's the first reason. The second reason is the AP Psych test will be going on, so I can't make it. We haven't had announcements all week. So you'll just have to, at 3:20, you'll have to tell your teacher in fourth period, hey, coach, hey, teach, can we go out in the hallway and cheer on the baseball team? They're going to go play the Drips tonight. I think it's 3:20. Yeah, 3:20. That's 3:20. They changed it. Yeah. I mean, whatever. You can tell your teacher 3:15. That way you get up there 5 minutes early, get a good spot. So you're not fighting for the front row. Is that what y'all call dripping springs? The drips? No? Drip? Oh, drip. That almost sounds like a compliment, right? When you say someone's drip, they got drip going. Yeah, but you don't want to compliment them. You should call them like the runny noses, like their nose is dripping. Yeah, that's not a compliment. You're playing the runny noses. What do you mean the runny noses? Well, it's drip, drip. Their nose is dripping. Yeah, they're little snotty people. Yeah, the runny noses. We're playing the runny noses. Or the RNs for short. We're playing the RNs. Who are the RNs? Dripping Springs. How do you get from Dripping Springs to RN? Long story. Runny noses. All right. Yeah, don't call them drip. That's a compliment. That makes them seem like they're snazzy dressers. All right, you don't want to do that. All right, example 5. Find the simplified exact value of sine of 35 pi 12 by finding two angles from the unit circle. Okay, so just like we said yesterday, you can find the cosine of anything that's a multiple of 15 degrees or pi 12ths. You can do the same thing with sine. Okay, so 35 pi 12ths. I need to find two angles that add or subtract to give me 35 pi 12ths. So remember the way you do this. You look at the factors of 12, which are 1 and 12, 3 and 4, 2 and 6. Okay, and you try to find some numbers that have factors in common with 12 so you can divide it out. So what can we do with 35? Let's just think about what we can do with 35. Now let's think about 35 for a second. Is 35 pi 12ths more than one rotation? Yes. Okay, so let's look at 35 pi 12ths. If I subtracted out a full rotation, I would get a coterminal angle, wouldn't I? And don't coterminal angles have the exact same trig values? Yeah, so I can make the work easier on myself by subtracting out a full rotation, which is how many pi 12ths? 24 pi twelfths. Yeah. What's 35 minus 24? 11 pi twelfths. That's going to be a lot easier to work with. Now, is 11 pi twelfths equal to 35 pi twelfths? No. 35 pi twelfths is coterminal with 11 pi twelfths. And remember the symbol for coterminal that I'm trying to get the world to use? Yeah, it's like a circle with an equal sign going through it. That hasn't really caught on worldwide, but Natsu will take that back to Japan with her, right? And spread that symbol in Japan. Can you help me? Yes? Yeah, thank you, Natsu. See? It's going to go global. Yeah, I made that symbol up because it looks like an equal sign and it looks like a theta. So it's perfect. I think it's the perfect symbol for coterminal. I don't think so. I'm trying to spread it to Japan before I spread it even across the hall. All right. Now, because they're not equal but coterminal, they actually have the same value. So here's what I know. I know sine of 35 pi twelfths is actually equal to sine of 11 pi twelfths because coterminal angles have the same trig value. Okay, so now I can work with 11. So what are some of these values over here that give me 11? Could I use 12 minus 1?
You do 3, 6, and 2.
3, 6, and 2. How about 8 and 3? Yeah, I just want to use numbers that have a common factor with 12. It doesn't have to be those. Okay, it could be anything. So let's try that. Let's try sine of 8 pi twelfths plus 3 pi twelfths. And that should work because 8 and 12 have a common factor, don't they? And 3 and 12 have a common factor. Now, why can't we use 12 and 1? If I do 12 pi twelfths minus 1 pi twelfths, 12 pi twelfths simplifies down to pi, which is okay. But do I know what sine of pi twelfths is? No, I don't know what sine of pi twelfths is, so that's not a good choice. But 8 and 3, those add up to 11. And if I simplify those down now, what's 8 pi 12 simplify to? They have a common factor of 2. They have a common factor of 4. They have a common factor of 4. 2 pi thirds. 2 pi thirds. It is early morning, right? It's already 9:09. 3 pi twelfths? You're thinking about the Wordle, aren't you? Yeah, you are, right. Your brain is preoccupied, trying to multitask. So there you go. That's how you find the two numbers. Get it down to within one rotation, and as long as you're using numbers that have a common factor with 12, it should simplify down to something on the unit circle. All right, so that was the first task. Find the two angles that added up to a coterminal angle, and now we're ready to rock and roll. Now we can use the identity, yes? Sine of the first, it's like we're distributing, but now sine is selfless, so cosine goes second. Sine, same sign. And now it's sine of the second angle. They switch angles. And then cosine of the first angle. And once you get it down to here, now you should be home free. Because now what time is it, everybody? It's unit circle time. What's sine of 2 pi thirds? This came up this morning on a BC calculus question. They had to know what cosine of pi thirds was. That's square root of 3 over 2. Good. Cosine of pi fourths, square root of 2 over 2. Sine of pi fourths, square root of 2 over 2. Cosine of 2 pi thirds, 1/2. Negative 1/2. Ah, your brain is back on math. I like it. It's in quadrant 2. All right, and now we multiply straight across, and you get the square root of 6 minus the square root of 2 all over 4. You might be able to go straight to that step because it's going to be the same thing every time. The only difference is your square root of 6 and your square root of 2 might be different signs. They can be both positive. They can both be negative. One can be positive. The other one can be negative in any order. All right, there you go. Do we need to verify on the calculator, or you feel pretty good about it? I think we're good. We don't need no stinking calculator. You know what? We are the stinking calculator. If the calculator should verify with us, that's right. Yeah. Okay. Any questions on it? The problems are getting a little more interesting, right? You like this better than proofs? Okay. Hey, guess what? the double dual class is having their proof test today, and they were walking by me yesterday when they were leaving class, and they all had looked forlorn. Their face was just dragging on the ground. I was like, "What's wrong?" And they're like, "Trig proofs suck," because they were getting ready for their test today. And they're doing all the identities. So there's a lot more identities that we haven't covered beyond the composites. There's double angle identities, there's half angle identities, there's power reducing identities, and they got to have all of them memorized. And the proofs get a little more interesting because you have more at your disposal, right? And they're just like, I hate trig proofs, and I'm like, you should be in my class. All my kids love trig proofs, right? I teach you to love them. She teaches them to hate them. Okay. Brady asked for a mental health day today, and I'm like, it is a mental health day. We're doing trig, right? That's right. Okay. Let's move on to example 6. Write each of the following as the sine of the cosine of a single angle. Okay. So we got sine of 22 times cosine of 13 plus cosine of 22 times sine of 13. This is going to end up condensing, we call it condensing, down to either sine of a given angle or cosine of the given angle. Now, if you look at it, which identity family should it come from, the cosine or the sine composite? It comes from the sine composite. Why, Kenzie? Sine is first, and in the same term, cosine is second. So it alternates sine, cosine, right? Now, this is not written in the way we want, so let me go ahead and rewrite it. Sine of 22 degrees, cosine of 13 degrees, that's how I like it. But this has the angles the same and the trig functions flipped, and I don't like it that way. I like to keep the trig functions the same, and I like to flip the angles. It's just my preference. Okay, now I can condense it. Y'all said it was going to be a sine. Am I going to add the 22 and the 13, or am I going to subtract the 22 and the 13? Add, because, say it with me, sine, same sine. Sine, same sine. Sine, same sine. Sine, same sine. I got to put the de Grobel. Absolutely. Very good. And then I add the 2 to get, see the de Grobel, it's not even known as the de Grobel nationwide. It's known as the de Grobel in this classroom and soon to be in Japan. Thanks, Natsu. The de Grobel. What's 22 plus 13? 35 degrees. Do we need parentheses around the 35? Nah. There you go. Now, are we able to find the exact value of sine of 35 from the unit circle? We can? Well, I don't know sine of 22 or cosine of 13. So the way it was split up is correct, but it doesn't help me in evaluating it from the unit circle. Is 35 a multiple of 15? No. So unfortunately, I can't find this using the knowledge that I've memorized, okay? I could use maybe an infinite series once I learn BC calculus. Maybe I can approximate it using a polynomial of degree n. But right now, unless we have the calculator, which by the way is programmed to evaluate it using a polynomial of degree n, we're just kind of stuck. So that's not what the question was asking us to do. The question was just asking us to condense it down, and we met the requirements. All right, next one: sine minus cosine. Hey, something fishy about this one. Does this belong to the cosine or sine family? It's cosine, right? Because they're paired up together. Cosine, sine. But it's in the backwards order, right? So let's put it in the order that we're familiar with. Cosine's like, what am I doing at the back? I should be in the front. It's my identity. Cosine, me. All right, now the negative is still associated with it. Yes. Yes. We didn't learn it that way, did we? So guess what I need to do here before I can evaluate it? I need to make the cosine x, cosine of 2x, I need to make that a positive term. Factor it out. I can't just multiply by -1 because that changes the value, but I can factor out the negative. Very good, Peyton. That's cosine x, cosine of 2x, minus, it changes the sign of the second one, sine x, sine of 2x. And now the negative is just a constant multiple. It just goes along for the ride. It's a -1 out front. Now it's cosine minus sine. Right? Now I can condense it. It's going to be a cosine, and then the angles are x and 2x in that order. X and 2x. The order matters for cosine and sine, right? Is it going to be a plus or a minus in between them? It's going to be a plus because it's opposite. Very good. Opposite. So this becomes negative cosine of 3x. And there's the answer. So your first step for doing these is to put it in the familiar order that we memorized it. Sine, cosine, switch angles, or cosine, cosine, sine, sine. Sine, same sign, cosine, opposite sign. Sine, same sign. Sine, same sign. Sine, same sign. Sine, same sign. That devolves very quickly. I still like that Marine Corps poster meme that I made a long time ago. Isn't that good? Have y'all seen that? Yeah, have y'all seen that? I think it's funny. I look at it every day and I just kind of smile.
What does it say?
You know, okay, so here's the situation. If you're listening at home and you don't see the poster, it's a Marine Corps recruiting poster, and it has a guy on an obstacle course, and he's way up high getting over this big like telephone pole looking thing, and he's struggling to get over it, but it looks like he's going to make it. And then there's another Marine Corps guy behind him that's running full speed at him with his mouth open, yelling. And I can only imagine that he's yelling, "Get over it! Get over it! You can do it!" Right? He's not trying to scare the guy or kill the guy. He's trying to motivate the guy to get him over the telephone pole. And then there's another guy behind that guy that's kind of blurry, and he's not as excited as the first guy. He's there in the background, and I think he's still supporting the behavior of the other two people. He's just not as into it, right? But he's there like, yeah, I support. I condone this process, but I'm just not. So the guy getting over the telephone pole is you. The telephone pole itself is the math problem. I'm the next guy in line motivating you to get over that math problem. And then your dad is in the background saying, I agree with this whole process. Right, Ryan?
Yeah.
I've talked with your dad several times about you getting over the telephone pole in here.
Does he really?
Yeah, you didn't know that?
No.
I saw him like at every football game this year when I hauled Buford, and we always talked about you. We talked about your sister too, but it was just like she's doing well.
Yeah.
Yeah. So we had conversations about you. You've never noticed that poster? Oh, yeah. I think it's kind of funny. It's true. It's actually true, but I think it's kind of funny, right? All right. Your dad. That's your dad. Your dad wants you to succeed, but it's not his job to get you over the math problem. It's my job. But he's all right. He's supportive. Okay. You could change your dad with something like your mom. You can, but it's a dude back there. Maybe you could put your priest or your pastor, right? Whatever. Or you could put Mr. Hughes. Maybe that could be Mr. Hughes back there. I don't know. No. No. All right. How much time we got?
Like 20 minutes.
Oh, okay. So here's the question now. We're at a fork in the road. Do we want to learn tangent today as well? Or do I want to give you the last 20 minutes to work on your homework with sine? You have an AP test this afternoon? Psychology? Okay. Well, here, I think learning sine for today is enough. I'm okay stopping here. We will finish the notes tomorrow, which means the homework is going to be due when? Monday. That works well, okay? All right. Any questions on today? Sine is selfless. It trades off, sine then cosine. Sine, same sign. And then switch the angles. Sine, cosine, switch the angles. And then cosine is selfish. Me. Cosine, change sign. Sine.